Hello and welcome back to the Oxford MAT Livestream. My name's James and today we're going to be talking about algebra. You know what to do if you're joining in live. You can get a copy of the algebra sheets, which is at the top of my screen on the MAT Live homepage. If you haven't already got a copy, you can get that over at www.maths.ox.ac.uk/r/MATLIVE, MAT Live, and you can play along while we're going in Slido, which is what Hector has done here. Hector in chat, who says hello. A Slido chat is also where we run polls like this How's Your Day poll, where you can vote on a scale from 1 to 5 of what sort of day you're having. And while you're doing that, loading up your worksheets or having a look at some algebra questions, I want to tell you about test registration. This is now open. It's opened earlier this year than last year, so that people have got more time, but you should make most of that by registering now. If you're going to take the maths submissions test in October 2025, because you're applying for maths or computer science or joint honours at Oxford to start in 2026 or deferred entry 2027, but mostly this is for people applying to start in 2026, taking the test in 2025. Well, they need to register at time of recording, starting now. The sequence, actually, I found out you need a UCAS number to register. So you actually need to go to the UCAS website and start an application over there first. You don't have to submit it, of course. You don't have to write your personal statement or anything like that. But if you start a UCAS application, you get a number, and then that's one of the things that we ask for when you register for the test. We're encouraging people to register early. This is not the step where you actually book for when and where you're going to take it. That comes later on. I'll have lots of reminders later on, but just to be signed up to be in the right place to book a slot to do this test. And that's a step that we can start doing now. Hello to Jacob and Anonymous K, Anonymous and Joe. Thank you very much for joining in chat. Good evening. Hello to people over there. You have reminded me that you can be anonymous in Slido chat. One of the reasons that we're using Slido rather than YouTube chat gestures vaguely to where YouTube chat would be is that you can be anonymous in Slido if you like. Hi Ruben as well. A few people have voted in this poll. They are having a 4.3 star day, except for a couple of people. I think it's only one or two who are having not so good a day. I'm looking out for them as well, because there's some chance that what they really need is loads of algebra to improve their day. Some chance on that. We will find out. Hello, Nathaniel, Anonymous Cubed, and Fig Roll in chat. There's a minor biscuit sub-theme going on with this. Right, let's stop the poll there, I think. Welcome along. Oh, just 5 stars has just taken the lead between 4 and 5 stars. There we go. Let's stop that one. There we go. I'm going to switch off chat so I've got the screens up as well. And hi to the user who's put hi in the username box and in the chat message. You're allowed to do that. You're allowed to duplicate your chat message between the two. You can put anonymous in the message box and all of the thing you wanted to say in the username if you really want to. Someone's going to do that now, aren't they? As proof of concept. Great, right, okay. Here is on screen information about tests, which I'm assuming you've now seen. I have to put it there at the start, right? So that I know that you've seen it. That's going to go away now. Let's do some maths. Maybe you've seen the questions already. Maybe you've had a look through the revision notes that's up there. I just want to point at the maths syllabus. This is a list of things that we think that students can do by the time they get to the test. So maybe you've seen this already. Maybe there's some of it you haven't seen yet. It says simple simultaneous equations in 1 or 2 variables, solution of simple inequalities, binomial theorem with positive whole exponent. I've got a bullet point about that in a moment, and then combinations and binomial probabilities, which is probably one of the things I get the most questions about, because, well, what does that mean? What does combinations and binomial probabilities mean on this? So I've got some revision bullet points to try and put together what I think that means. The math syllabus at the top is very official. That's the published thing that we've got, which says what the topics are, and then the revision notes are a little bit more informal, with me trying to remind people what that means or how you might solve simultaneous equations. I hope you're not learning how to solve simultaneous equations by this live stream, but if you are, then hi, welcome along. You can solve them by substituting one into the other, do some rearranging, see what you can work out as a result. New for this year, we've put in some descriptions about how you might manipulate inequalities with variables in. All my examples last year had numbers in. You can handle variables in there as well, so we now have such delights as if x is less than 2, then x plus 3 is less than 5. Although I seem to have left it as 2 plus 3 to make a point, right? 2 plus 3 is 5. Welcome to the Oxford MAT Livestream. The thing I want to highlight, so I'm skimming through these quite quickly. If you want to read these, they're on the page in the document. You can get a PDF, which is what I'm scrolling through, or you can get a web version, which is formatted so that it might look better on your phone or tablet or whatever. It might resize. The PDF is nice for your printer, so if you print something or look at it on your phone, those are different applications, different shapes of content, aren't they? Right, I've highlighted the binomial theorem as something I wanted to tell people about. I've listed it in the revision notes in all its glory, with a big ... in the middle, and with these things called binomial coefficients. These things, I've written them like this: n choose r, to mean this thing, like this, which you might know as when n is 2, these are the numbers 1, 2, 1. When n is 3, these are the numbers 1, 3, 3, 1. And maybe you know the ones for n equals 4, that these are 1, 4, 6, 4, 1, or something like that. Maybe that's as many as you could recognise or something. Who knows? Or at least you can work them out. Hello, Anonymous. You haven't missed anything yet, except for the obvious. I've said hello. We've done a poll. We've scrolled through some bullet points. You can get anything that you miss by either rewinding the live video, watching the replay, or looking at the notes that I'm going through. Not missed anything yet. There we go. Right, there's a request for questions, which I will get to. I want to go through revision notes quite quickly this time, so that we can do some revision questions. Someone said question 3 is hard, and I think I agree. And then I want to do some math questions. We did about an hour of revision last week, which, yeah, you know, if it's what people want, it's what we'll do. Okay. The point I wanted to make about the binomial theorem is, well, partly I've been a bit silly in the way I've written it, right? On the board at the top there, in the notes, I've written things like n choose 0. Oh, by the way, I'm saying n choose because it's something to do with choices. More about that in a second. And some people write it n large capital C R down here, which they also pronounce n choose R. That's maybe how you choose it. How you choose to use your coefficients. I've been a bit silly with the expression I've written up there because maybe you know that n choose 0 is quick maths, n take away 0 is n. Oh, wait a minute, this is 1. So perhaps when you learnt the binomial theorem, somebody simplified that for you and just wrote x to the n for that first term. I'm being a little bit silly. I've written out all of the terms, including things like n choose n, which is n factorial divided by n factorial, n minus n is 0. Welcome to the Oxford MAT Livestream. There's 1. I've listed both. Whereas perhaps a more familiar thing to do would be to write x to the n plus n x to the n minus 1 y. So to write out what those first two coefficients are. You sort of know some expressions for some of these. Or you could work them out using this rule, which I had a chat with an A-level teacher who said that not everybody knows this rule for the binomial coefficients. Some people just know them as a button that you press on your calculator. That you press a button like 3 choose 1, and it says 3 choose 1 is 3. I think for maths, we're hoping that people have some understanding about where these things come from. Maybe they have some experience of multiplying out x plus y to the power of 3, or if not, try that now, so that you can write these down even though MAT is not a calculator test. And that's some sort of experience and fluency, I suppose, or maybe it's knowing a formula, or maybe it's just having done some things. I think explicitly knowing that formula, probably a good idea. I've got a paragraph coming up in a second about where it comes from and what's going on here, which should be the sort of thing that you're thinking about, I suppose, the thing about maths test questions. Oh, let's put this backlight on. Oh, that's a bit better. The thing about maths test questions is that they reward you for having thought about the material or finding links to think about what's really going on. I'd like to do that by showing you what's really going on with these numbers and their word formula. Right, okay. Yeah, it shows you where the numbers come from, but it shows you where the numbers come from, says Figrol, but of course, then you have the question, this is where the numbers come from, but where does this come from? Question mark, question mark, question mark. Where did the formula come from? Good. Do you happen to know, says Connor S, yes, probably, if the MAT is able to accommodate a maths word processor like Equatio? My understanding is that it is not, although I don't really know what Equatio is. If it's an access requirement, then register for the test now and talk about access requirements when you register for the test. There's a box for this. I mean type, not talk. So if you're asking about an equation, if you just want to have a word processor to format your maths, then good news. The questions are written so that you don't need to do that. Right, good. And then should I apply to Oxford or computer science if my predicted grades are 2 A's and only 1 A star? I believe for computer science, let's put chat on quickly since I'm talking to chat. For computer science, I believe the standard conditional offer is A star AA. I'm going to fact check myself live. Do you know how I'm going to do that? I'm going to type into the internet computer science Oxford entry requirements. I'm going to click the first link that comes up. Ah, good, it was a good one. I'm going to check the admissions requirements. Tiny screen, tiny screen. A star AA, including A in maths, and with the A star in maths for maths or computer science. So, yep, fine. If you're predicted it's an A star and 2 A's, then you're predicted to meet the grades that you need for the course. When it comes to A-level grades, it really is that simple in most cases. A-levels are useful in that they show us what you're doing in school, but we've got other things. Other than looking at, is this person going to exceed their grade in chemistry or something, like A star in chemistry? Rather than looking at that, which I would have opinions about, we have a maths test instead. That's why I'm doing a live stream about the maths test and not a live stream about getting your grade up in the chemistry A-level. Hope that all links together. Anonymous, you're fine. Right. Would it be fine to just do Pascal's triangle? Oh yes, so did you see at the top of the screen as well, there was a Pascal's triangle suggestion, which is somebody in chat saying that the thing they know is not memorizing the rows or memorizing the formula. The thing they know is some rule about where these numbers come from, that 3 plus 3 is 6 and 3 plus 1 is 4. So they can generate these numbers. That's obviously fine. Do what you like. I think having a few different ways to do the same thing is probably good for you. Just generally in life. There you go. You get life advice with the MAT Livestream now. Oh, I've erased some of the number 4. That's unforgivable. Okay, let's talk about where that formula comes from, because there it is in all its glory: n factorial over r factorial, n minus r factorial, where factorial means factorial. Yep. And one more thing. Yeah. Okay. Quick look at chat, sorry. We're going to find out where that rule comes from, because it says, why does Pascal's triangle adding rule work? Yes, good question. Different levels of answer, right? Easy answer is just, well, the reality is that they are these, and these things satisfy the adding rule. That's not a very satisfying answer, so there's a deeper level as well for what's actually going on here. But if you like, we're going to understand where this formula comes from. You can check that the formula does the adding rule, and then you're all good. And also, do I need to make an application for Oxford before registering? No, you need to start a UCAS application. When you start an UCAS application, you get given a number. That's the number they're looking for. You don't need to submit your application. The deadline for that is 15th of October, but you need to start an application to get a number. Do you have to do some competitions beneficial for personal statements? We're going to look at your personal statement, but rather than looking at the details of which maths competitions you've done, we've got a maths admissions test, which is why I'm doing a live stream about the maths admissions test, rather than about getting your grade up in the BMO or something. Right, here we go. Here's the rule for where that formula comes from. I've written this out in a proof. The revision notes don't have many proofs. This is one of them. I think it's healthy for you to have seen this maths at some point in your life. It's a justification for where that formula comes from. Let's go to full screen mode very quickly, just to get all of it on screen at once. So I'm just going to talk through it a tiny bit. If this is news to you, then you might like to get the, it's above me as well now, you might like to get this worksheet and just have a quick look at this paragraph. The argument is about over-counting. The argument is about choosing things. So I need to do two things. I need to convince you that when you choose R objects from a list of n things, that there are n choose R, the thing in brackets, n choose R ways to do that. So that's the first thing I need to convince you. That's what the paragraph does, thinking about counting, how many things are there. Combinatorics is about counting. Anyway, never mind. I've realised the other thing I need to convince you of is that that's the right thing to put in the binomial expansion. So let's have that on screen just for a second. More than a second, sorry. Don't panic. Let's have that on screen. And what I'll do is down here, I'll explain the link between choosing R from n and the binomial expansion. Links between different things is one of my favourite things about maths, that things are connected. It's just great. So recap, on screen at the top there's a bit from the notes about an explanation for this formula, but it tells us that the formula is correct for choosing and making choices. Maybe not everybody has seen this rule for what's that got to do with x plus y to the power of n. So I'm going to multiply this out, or rather I'm going to write this out lots of times. And I'm going to invite you to think about what would happen if I spent the next hour and 3/4 multiplying out all of these brackets. Answer, everybody would switch off the video in about 3 minutes time. Other than everybody giving up, what I would do, I think, is I would start to break the brackets apart. That's quite fun to say. So something like I would have x times and then all of this in some sort of humongous bracket. Let's make that bracket more humongous. Whoop. X times all of that plus y times all of that. So I'd start to get these terms that have x in them and these terms that have y in them. And maybe I'll just keep breaking things apart, and this is pretty horrible. It's not clear at all what I'm going to get if I do that. So there's an alternative way to think about this, which is to say when the dust has settled and I combine the terms, I'll get lots of terms like x to the n plus x, 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 dot, 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 x, y, from like the very last thing I chose, x, y, x at the end. So sort of listing all of the things that you could end up with in, I think this is an order. This is sort of lots of x's, and then there's just a y at the end, and then maybe there's just a y here, or two y's. If you know about binary, there's a link here to binary. How many of these things are there overall? 2 to the n, because of binary. So we've got this like x to the n, and then maybe this x, all the x's, but then in the last bracket I was multiplying out, I went down the y route instead, maybe some sort of branching binary tree. If you know about binomial probabilities, branching trees, branching processes, you've got this kind of probability tree of probabilities. It's a binary tree because it splits in 2 at each time. It's related to binary numbers. Anyway, never mind, everything's connected. The point I'm trying to make is that some of these things look like the same, right? That this is x to the n minus 1 times y, and this is x to the n minus 1 times y. The things that I've made before I simplify them, and obviously multiplication is commutative, so I will be simplifying them, but before I simplify them, I've got expressions that are n things in a row. Let's go, so this is n things in a row. Some of them are y, the rest are x. And then the number of such terms with, let's say, y to the r, if I want r, that's how many I want y's, well, the number of times that happens is the number of ways to choose r of the things to be y. So there's this really nice link between just the choices about whether you take an x or a y while you're doing the multiplying everything out before simplifying. There's a lovely link there between the choices that you make. Each thing ends up being an x or a y as you're writing down this long string of n things. And after simplifying, you'll collect things together, so you only care about how many of these things were y. You don't care about order. So there's this lovely link between choosing and how many of these things you get gives you the coefficient. Yeah, so there's a tree going on. Anonymous says, I look at your live stream and think that this is easy, then I go and look at a past paper and think that this is hard, roughly speaking. We are going to do some past papers as well. Yes, are the large brackets somebody with the username associativity of multiplication, who I wasn't ignoring, but let's put them on screen now because they've said something clever, so let's put them on. They've said associativity of multiplication as their username because they're very keen on simplifying things. Whereas the way my argument works for that bit is don't simplify it yet. Don't simplify it yet. Also, I think there was a point in there where I had very large, humongous brackets that were there to help you read it. Brackets for multiplication, brackets to group terms together, but also brackets to keep terms apart. Okay, that was quite fun. Okay, so this is the sort of link, in case you've never seen this before, of what the link is between choosing and binomial expansion. If you'd like to practice this, an activity you could try at home is something like work out, this would be fun, work out x plus y cubed by multiplying out one bracket at a time. But here's the catch, no simplifying. So if you see x times x, I don't want you to write x squared, just xx. It will feel really awful because you're so used to simplifying things. But I want to see things like xxx and yy will be in there somewhere. I want you to see all 8 terms. All 8 terms. And once you've seen them, hopefully you've got an idea of what's going on. And that idea generalizes. Good, right, okay. Good, help as a username in chat says, what order should I work through the resources for admissions tests? I would start here and look at some past papers, and if you like, you could go to the STEP support program in parallel. So the foundation units of the STEP support program from Cambridge are also good and also supportive for this sort of syllabus. The STEP support program goes much further. So if you're getting ready for STEP, then you might start here. You might start doing STEP in parallel, STEP support in parallel, and you might move on to other STEP support programs later on. You can add in Stephen Siklos' book whenever you like. It's mostly past paper questions, so I guess maybe I'd intersperse it, do a bit of STEP support, and then look at Stephen Siklos' book, and then some past papers. That would be my sequence. This is designed so that you can just do this. Good, but if you're also going for STEP because you're applying to Warwick, or I suppose if you're applying to Cambridge instead of Oxford, then hi, nice to see you. You could also merge in some STEP support stuff. Right, good. Free advertising for Cambridge. There we go. There's a question in chat about permutations. There's some stuff on screen about permutations. I would learn about permutations if I were you. I just don't think they're very hard to learn about. That bullet point is much shorter, right? It relates to the previous one. It's the argument about overcounting, which you might have seen before. And then there's this application to talk about probabilities, where really the only probability fact I need for people to know is this thing about the probability in a very particular situation. I don't know, there's a factory that has lots of light bulbs and each one is rubbish. It works with probability P independent of the others. What's the probability that exactly 10 out of the 40 light bulbs work? And, well, which 10 is part of the answer, and there's a formula for it on screen. Okay, right. Rushed away from that, I think, a little bit. Let's do a vote, because next up is going to be revision questions. There's a long list of revision questions. There are about 14, and I saw in chat somebody wanted to do 3. Question 3, but there's a vote for this. You can vote for as many as you like, so we'll set that off in Slido. Here's a quick look at Slido. And I just wanted to do something from chat. Yes, what was it? Other revision resources you would recommend? I also like, well, hang on, I was going to say the support from AMSP, but I'm not sure if that's currently live. If you're watching this in the future, find out the support from the AMSP. And really anything you can do that's tricky. I was a little bit flippant early on about competitions or doing other things like chemistry, but anything that's challenging for you to try some tricky things where you get to get your brain working, it's probably good for you. Why is there so many votes for question 3? Has question 3 got a typo in? Oh no, it's just hard. No, I've looked at it now, it's just hard. Well, that's my future. And there's a question about unordered versus ordered. All of the stuff I've been doing so far on the screen, if you're choosing 5 things from a list, if you're choosing smaller numbers, sorry, if you're choosing 3 things from a list, maybe it doesn't matter what order you choose them. So there, I coloured them in left to right. Maybe that's the same as if I'd coloured them in from. Oh, let's do the same. Maybe that's the same as if I chose that one and then that one and that one. It looks like the same final picture, but maybe this wasn't a picture, maybe this was a video. I mean, it's clearly a video, you're watching it. In which case, the order of the choices matters. Concretely, if you've got lots of shoes and socks to put on, then lots of shoes and socks? Wait, you've got to choose, what am I talking about? I'm thinking about this caterpillar that's got loads of shoes and socks, but it's not the right example to do right now. Let's do the smoothie example. So if you're planning a smoothie, and then you put some fruit and veg in, but it doesn't matter what order because you're going to blend it. You get the same smoothie out at the end. But if you're planning something where the sequence matters, you want something first and then something second, and it's really important to you which. I don't know, you're handing out medals at the Olympics. You'll choose someone to get the first medal. I suppose you'll let them do their sport or whatever, but you'll choose one person to get the first gold medal, and then you'll choose someone to get the silver medal. And then everybody without the medals, who cares what order you've finished in? Right, like the order could be, if the first one I do gets a gold medal, and the second one, let's go gold, silver, bronze. That's totally different to if I colour them in the other order. Choice matters. In terms of the formula, there's just a different factor in there to allow for the orderings. Right, so AMSP's funding seems to have changed. They haven't got no funding, but they have different funding. It is not immediately obvious to me at the time of recording which things are going on. And important question, in 2025, you do not pay to take the MAT like you do for TMUA. There's this other test called TMUA, which is charging candidates to take the test. But in 2025, like in 2024, MAT is not charging candidates. Suggestion for 12, and 12 is doing pretty well in this poll, so there we go. Right, so I think the priority list from chat there is something like 3, and then 12 and 13, and then is it? Oh, and then 9. That's interesting. 9 is a bit vague. I might do 9, and 11 is also in there. People want to do the choosing stuff, 12 and 13. Okay, so maybe 9, maybe 11. Okay, we can do things like that. Let's see how we do. Good, anonymous. So Owen in chat, I forgot to mention, Owen is in chat again. It's Owen from last week. He is back in chat. Anonymous has just asked, did you do the undergraduate programme at Oxford? And I'm smiling because neither Owen in chat nor I did the undergraduate programme at Oxford. But here we are at Oxford running the show. Lots of people switch universities during their careers. Owen is a current student who studied elsewhere but is now with us for Oxford. Good to have you on board, Owen. Right, okay. How good is IB math syllabus for MAT preparation? It should be pretty good. It's pretty similar. The point of these with the revision notes and the MAT syllabus stuff at the top is so that you can compare. So that if you're doing IB or something else, French B, French Baccalaureate, or the other ones, then you can compare what you're learning in school with what people are doing in A-level maths. We used to say this quite vaguely, like equivalent to A-level maths content, and now we've got this like revision notes up there somewhere, or more realistically on the website. You can have a look what we expect people to know. Right, okay, question 3 then. We've got simultaneous equations. They're a bit tricky. What do they say? They say x squared plus y is equal to 2. And they say that x plus y squared is equal to 2. So part of me really wants to take the difference between these. So there's one route you can go. I think if you take this equation, first equation, rearrange it for y, and substitute, you will get an equation. I don't know if it's going to be a very nice equation, but you will get an equation. In fact, this looks like it's going to be a 4th degree equation. My goodness, degree 4 sort of thing. So that doesn't sound like fun. Possibly you can then spot a root, which relates us back to polynomials. Should we go down that route? I've got to multiply out this square, which, to be honest, I don't even know if I'm using the binomial formula or if I've just done so many of these that I know that there's an extra factor of 2 to watch out for. And 4, but take away the 2, so 2 plus an x plus 2. Possibly you can spot a root of this, factor theorem time. Can I spot a factor of this? Can I remember the solutions to this equation? No, I can't. I've lost a solution. What have I done wrong? If I messed up. Wouldn't be that surprising if I messed up. Yeah, shouldn't I have 1, 1? 1, 1? 1, 1, 1. Yep, 1, 1. Good. Ah, yes, Ruben spotted a factor in chat. I was mumbling to myself about what I thought the factor was. Thought, yeah. Is there a quartic equation? There is a quartic equation. You won't like it, and you're not expected to know it for MAT. Just for the comedy value. Can I try and get that up? No, that's not good. Don't Google it. It's not worth it. Okay, so we could keep going from there. But there's another suggestion in chat from Anonymous that is also a feeling that I had to equate both of these, which is maybe a bit less standard. I don't know where this is going to go. We talked last week about the journey into the unknown, the kind of sense that if you do something like this to take the difference, then I don't know where this is going, but okay, maybe we can make this work. We talked about 2-step solutions, didn't we? And saying how you've got to give yourself the opportunity to be in this position where maybe you'll back yourself to spot something. So for me, this is making me think quadratic equation or quadratic complete the square. Yeah, equating these together, this feels quite nice. It feels like I'm treating the x's and the y's together. If you're playing along over on this side, I think you've got a factor of 1 and you're doing some polynomial division like we talked about last week. So no factor of x cubed minus x squared minus 3x, but I actually want 1x, so minus 2. So you've got to spot another factor now. But if you spot one more factor, then I think we're good. Because I think if you spot one more factor, then this will fall over and we'll be left with a quadratic. Oh, excuse me. Sorry, that was a really bad scraping noise, wasn't it? So we've got 2 parallel things going on here on screen. On the left of the pink line, I've got some attempts to equate these, or take the difference if you like, to say both of these are 2, so these are equal to each other. And then I've rearranged them like this to try and get the x's with the x's and the y's with the y's. I'm thinking about completing the square. And the nice thing is that the things are the same on both sides. So that's quite good. So does that tell me something like either x is equal to y or something simple? Yeah. Oh, x plus 2 is x. People are really good at this game. Over on this side, on the right of the pink line, people are factorising further. X squared minus x minus 1 equals 0. And then you've got a quadratic, so you can use the quadratic formula. You should go and back substitute to find the values of y. People like this? Yeah. Oh, difference of two squares is an excellent suggestion. Oh, difference of two squares gets... I don't have any prizes, but difference of two squares is excellent. You see these? X squared minus y squared? I moved them onto opposite sides, but somebody in chat says no, no, no. That's difference of two squares. We should go, so we now need another pink line. Wait, another pink line. Another pink line to the left of this, over here, very, very small. X minus y times x plus y minus 1 equals 0. They factorised it, I think, because there's an x minus y in here as well. That's sort of mad. Cool, okay. So either y equals x, which feels like an easy case to then go and think about. We've still got to go and solve the equations at the top. I'm getting there here as well, or I suppose I'd have got there slower. Still got to go and plug this in. So I've got a linear equation now to plug in. It's nice and symmetric, isn't it? X plus y equals 1. I could go and plug this back in here, and then I'll get the same quadratic that we've generated over here. Everything's connected. It's got to give the same solutions both of us. Yes, so we could set y equals x back in there and solve. We would get two solutions. So x squared plus x equals 2 has got two solutions. They are 1 and minus 2. So this gives you a pair of solutions. 1, 1, and minus 2, minus 2, which is also the solution that you get over here for x, y. And this one gives you minus 2, minus 2. And then these ones are nice. The solutions here, on the right of the pink line, the right of this pink line over here, the idea was something like, well, we'd go and solve this and get x is 1 plus or minus root 5 over 2. And then we've got lots of work to do at the end. You can't really avoid the work here because I've got to go back and calculate y. Oh, I've got to look all the way up here. Y is 2 minus that thing squared, and go and simplify it. And it comes out nice. Y turns out to be 1 minus plus root 5 over 2. A rare use of the minus plus symbol. The idea being, have you seen these before? Maybe not. I don't think there's going to be one on the test, but he says as the person in charge of the test. Plus minus and minus plus are sometimes used like this. If when this one is a plus sign, this one is a minus sign. They're supposed to be paired together like that. But some people do this to indicate when the x has a plus sign, the y has a minus sign, and when the y has a plus sign, the x has a minus sign. Sorry, I just did that without really thinking about whether you'd seen it before or not. Here we are. Here we are. I've realised now that I looked absolutely mad, especially because I skipped the algebra over here. Sorry about that. Right, go and check this for yourself. Go and check the solutions of this quadratic. I claim are this number, and then if you go and plug it back in, there's a very, very boring step of algebra, and then you go and discover that, oh my goodness, the values of x and y add up to 1. It's amazing. Good. Why have we got 4 solutions? Can chat tell me what's going on? Why have we got 4 solutions? I suppose I don't really want a deep reason for why we've got 4 solutions, but could you guess that you wanted 4 solutions to this when you see equations like that? Anything about 4? Why 4, right? Oh yeah, golden ratio alert, by the way. Golden ratio. This question is designed, I think I wrote this. I'm going to act like I wrote this because I think I wrote this. This revisionist question is designed so that you get the golden ratio. Yeah, so quadratics in x and y makes me think about the number 2, but there's both, so maybe 4. It is a quartic when you substitute. So Nathaniel says in chat, chat's on screen now. When you substitute, you get to quartic, so at that point we can see 4. I've already done a lot of work there. Yeah, I don't know. I was hoping that someone would tell me that where you can draw graphs of these things, right? Y is 2 minus x squared, says the top one. And that goes through, well, what does that go through? 2 minus x squared is 0 at plus and minus root 2. And there's another one here, which is what am I talking about? X is which is the same but with x and y flipped. This is 2 up here, isn't it? I was a bit nervous that I was going to draw this wrong. I almost did draw it wrong, so that was good nerves to have. Looks like this. So we end up with, oh, I'm right off the screen. Bother, sorry. There you go. I drew it wrong, but then I was off the screen, so I fixed it. There we go. So maybe you could sketch something like this and think, maybe I'm going to get 4 solutions where these things intersect. It's quadratics. One of them is a sideways quadratic. Ooh, that's the second one. It's a rare sideways quadratic using y squared. If you like, it's got x and y the wrong way around. So instead of drawing it y as a function of x, you could draw a quadratic x as a function of y. Did I done that right way around? Yeah, I've done that right way around. There you go. Good. Okay. You do not need to know about complex numbers for the MAT. The questions are written as if you don't know what complex numbers are, because some people doing the test don't know what complex numbers are. You are not required to list or count complex solutions to equations, and questions will usually say real solutions, just in case. This one didn't need to because all of the solutions are real. Good. Okay. Thank you, chat. If I say something out of nowhere, for the people watching the replay, if I say something out of nowhere, it's because I'm looking at chat on a second screen. Even though it's not up there, I can still see it. Okay, that was 3. There are also some votes for 12 and 13, so we're going to go down there next. Is that them? That's them. I like drawing little sketch graphs. It helps me think about things. I don't know, there's like this algebra geometry thing going on where you can think of it just about raw algebra of what's going on with the numbers, or you can think about it slightly geometrically. You can. That was quite hard. I don't know if I'd say harder than a math question. I think you can do all of the individual steps, right? What I'd hope is that, if we're talking about question 3 still, even if you couldn't do the kind of stuff towards the end, that maybe you would have the idea of rearranging the first one to get y equals something to do with x, and substituting it into the second one. The stuff that was going on the right-hand side of the screen. To have the idea to go down that route. Now, maybe it gets a bit fiddly, and that's a thing to do with sort of fluency with working with polynomials, but at least having the idea to go and explore that direction. Or maybe not, maybe you did something else. Maybe you did none of the things I showed you just now. Maybe you did something else. Doesn't mean you're wrong. Doesn't mean it's not going to work. Maybe you're exploring a better way to do the question. I don't know. But if you saw that question and thought, I don't know what to do, good. If you thought, and I'm not going to try, then my advice for the next one is try, or just do whatever. Try exploring, see what goes on. Good. Okay. You can make the y-axis the x-axis by flipping in the line y equals x. It's a reflection like this. I think I'm doing that mirrored. A reflection like this. Okay, reflecting in the line y equals x. Okay, what's a good score on the MAT? About 70 is usually good, but you're aiming for 100 out of 100, please. And will we get any paper? You get some noteboard paper stuff. It's like laminated paper in some test centres. You get something to write on, yes. Good. Okay. Anonymous in chat's made me chuckle by asking for past papers from before 2007 when it had a different name. Even I don't have all of the test papers from before 2007 when it was different. Okay. So, question 12 looks like this. A game show has 10 contestants and 3 finalists are chosen at random. Shall I draw a picture? This is my idea of what contestants look like. 3 finalists are chosen at random. What's the probability that contestant 1 is a finalist? Let's cover in these. And contestant 2 is not. Okay. So we're being asked for the probability that when you select 3 things from these 10, some extra stuff happens. So one way to think about this is first to think about all of the possible choices of 3 people from 10. I'm going to give them names. This is my idea of what names look like. I am going to go for I and J, I think. I'm going to give them names. And I'm going to ask you to imagine, choose 3 here, so 3 finalists. There's a kind of listing approach to this, where you say, well, those finalists might be ABC, they might be ABD, ABE, and so on, through some sort of list of possibilities. And each of these is equally likely, provided I don't list any of the groups of finalists twice. Or if I do, I should make sure I list all of them twice. This is the thing about overcounting, right? You might think, well, choosing the finalists, maybe it doesn't matter what order they're picked in, or maybe it does. So long as you're consistent, everything works out. So I think choosing the finalists doesn't matter. I'm not told that it matters what order they're chosen in. I'm going to assume it doesn't matter. So I'm listing things like this. Maybe your list also has on it somewhere BAC. Mine doesn't, but yours might. The difference between our lists is that perhaps yours is 6 times longer than mine, but it's exactly 6 times longer than mine if you think order matters. I realize the word finalists makes it sound more like that podium that I mentioned before, so maybe that's the natural thing to do. Someone in chat has given me names: Amelia, Benjamin, Chloe, Daniel, Ella, Felix, Grace, Henry, Isla, and Jack. That's pretty good. They sound like quite Gen Z names as well, plausibly. I think that's pretty good. Good, right, okay. And the question is, how many of these are kind of all the possibilities. Doctor Strange looks into all of the possible dimensions to find out how many things might happen. Oh my goodness, whatever. How many of these possibilities have A but not B? Okay. So depending on how your list works, that might be different. For me, that's a kind of hangman puzzle to say I have A here, I have 2 gaps for the next things, and in hangman terms, I have lost 1 life because not B. It's not B. So if we're playing hangman, I've got to guess this 3-letter word. It's not really a word, is it? 3-letter word. I've got A, not B. So I've lost 1 life down here. Hangman. Okay. So what have I got left to guess? Well, I realise now. Oh, no, okay. We'll do it in a second. I've got 9 possibilities. No, I've got 8 possibilities for what else I might think about. What could this possibly be? What could it be? So for me, I would say that there are 8 possibilities for this, 7 possibilities for this, multiplying because there are independent choices here. 8 things for what that second finalist might be. It's not A again, and it's not B. And then 7, because once I've put somebody else on the final, I've got 7 choices left. But then divided by 2, because for me, the order doesn't matter. Now for you, if order does matter for you, then you won't do that divided by 2. You will have finalists that look like A, D, E, and also A, E, D. That's fine for you, maybe. You would also consider the possibility that A wasn't picked first, that they were picked second or third. So if you think that order does matter, then you don't have that factor of 2, and you also have a factor of 3. So not dividing by 2 and yes to multiplying by 3 gives you a factor of 6. So that's consistent with your first list being 6 times as long as mine. Okay, so I think there are 28 of these where I do have A on my panel and I don't have B. So I'm going to write that down over here as 8 times 7 is 56, divided by 2 is 28. How many of these are there? I didn't ask over there. How many of these? Well, that's 10 choose 3, which I can work out. That's 10 times 9 times 8 divided by 3 times 2 times 1. Don't particularly enjoy calculating these. Can I look at my answers? 10 choose 3. Oh, I didn't enjoy looking at that at all. Is it 120? 6. 72. 720 divided by 6 is 120. Brilliant. Okay. So our probability at the end is there are 120 things that might happen for this group of 3 people selected out of here. And I'm interested in just 28 of them. So my final answer is 28 divided by 120 for the probability. Now, each of these things are equally likely, and 28 of them I'm interested in out of 120. Yeah, so why didn't I divide by 2? Because I don't want to count, for me, I don't want to count ADE and AED would only be one possible set. If you like, this is 8 choose 2. This thing that I've written down here, 8 times 7 divided by 2 is 8 choose 2. So if you are happy with all the choosy stuff from before and you just want to write down a coefficient, then I'm choosing 2 things. 2 things from 8 to be the other 2 people. I'm choosing 2 of them because that's how many gaps I've got, and I'm choosing them from 8 because I know it's not B, and I've already got A. So 8 choose 2. So if you prefer to write everything with choosy combinations. I switch between them, I think. Sometimes I like to write a choice combination like this over here, and sometimes I like to think about what's going on, which is a bit like running the proof that I put in the notes in each case. Divide by the overcounting factor, that's the proof. There you go. 5 is 2 orders, compared to 1 compared to 2. Competitor 1 and competitor 2 are supposed to be distinguishable in this, right? Because competitor 1 is on the panel and competitor 2 is not. Why wouldn't you times it by 3 for each? Right, okay, here we go. I found the person. I found them. I've been talking hypothetically, but I have found them. Hello, I'm excited now. Anonymous at the top. I mean, so I haven't quite found the anonymous person at the top. Why wouldn't you times it by 3 for each place that A can go? For me, I'm only listing each group of finalists once. So I'm not listing BAC in my list. Now, maybe your list. I've been talking about you. Sorry, before I met you just now. Maybe your list, you have listed BAC. In that case, your list is quite a bit longer than mine, right? Because your list overall, if you're allowed BAC and ABC as kind of different things on your list, then your list will be, well, 10 possibilities for the first one, 9 possibilities for the second thing, 8 possibilities for the third thing. If order matters, then you'll get 720. Your list is 6 times as large as mine. For just how many ways there are to pick these finalists at all. And then you will multiply by 3, because for you, it does matter whether A is the first one or the second one or the third one. And you will not have this, you will have twice this, because for you, it does matter whether D is this one and then E is that one, or the other way around. But for me, it doesn't. I've decided it doesn't matter, and as a result, I've divided this thing by 6, and I've divided this by 6 as well, partly by ignoring a factor of 3 for which one is A, and partly by having a factor of 2 for not caring about which order these other ones are in. It does all work out. Possibly this is easier if you believe that order matters, because then you have a nice simple multiplication over here for how many sets there are, and you have a nice simple multiplication over here, and you get 56 divided by 720, which is the same fraction. Good, okay. Is it a bit overcomplicated? 3/10 times 7/9. Yeah. But can we throw? So this person on chat, he says, isn't this a bit overcomplicated for 3 times 10 times 7 over 9? I will draw your attention to the other person in chat who says it's obviously 3 over 10 times 7 over 10. If you don't have a reason, then you're on thin ice. So presumably you do have a reason as well for your 7 over 9 factor. But beware writing down a multiplication. Sometimes they speed things up, and sometimes it's because you've forgotten about coincidences. A coincidence there, I mean, they're not independent events. A being on the panel and B not being on the panel are not independent, because if A is on the panel, then B is slightly less likely to be on the panel. There's less space for them, which I think is allowed for in your factor of 7 over 9, but would not be allowed for in a factor of 7 over 10. The answer is not 21 out of 100. Good, right, okay. Should we do 13 as well? It's kind of pretty similar, isn't it? We've got a big list of things that might happen, and we're interested in a subset list. So I think if you replace the word girls with finalists, and you replace the word class with game show, then you have kind of different numbers for the same problem. So I think yeah. And then here's the chat message, just to follow up. Here they are. Only 9 people left because A has already been assigned a winner. So they're thinking about a sequence of events like a probability tree. Let's do that on the screen. I'm coming around to this as a way to do things. If you like probability, maybe you're thinking about how would you do this then? So your first event is something like A is selected, or the alternative is A not selected. And this one has probability 3/10, and this one has probability 7/10. And then in this world where A is selected, you could think a bit more about whether B is selected. And at this point, you're saying at this point, A has already been selected. So the probabilities around here are you've got two people left. So maybe this is 2/9, and B not being selected. Well, 7 of the other people are not going to be selected, so 7/9 possibility that B is one of the people not selected. That's the thing we're interested in. We're interested in this event, which has got, here we go, events that are independent, multiply together, 3/10 times 7 over 9. Does that give you the right number at the end? 21 over 90, which simplifies down to 7 over 30? Yeah, good, okay. I want to be really clear. Let's just quickly look over here. It's not really relevant for the question, but just... so if A is not selected, there are 3 spots in the finals, and 9 people who might be selected. So over here, the probabilities on these branches are different. They're not in the question, but the information about whether A is selected or not affects later on, if you're looking at the probabilities, that B was there or not. Good, okay. There is something called Bayes' theorem, there's something called conditional probability. You don't need to know either of those things for maths, but these things are real, and that means that there are pitfalls there that you should just work carefully, however much probability you know. This is also good advice later on when you're learning probability and statistics. You should be careful, no matter how much probability and statistics you know. Okay, that's 12 and 13. I'm about to hit 6 o'clock. I'm going to scroll and have a quick look at... I need to scroll on this one. That's all of my stuff. We need to scroll here for a quick look at 9, because it did quite well in the vote. Yeah, quick look at 9. Given A less than B and C less than D, there is a trap where this question, I definitely wrote this one. I don't think it's very good. The trap is for you to say, aha, AC must be less than BD. I can multiply. The question says, it tries to lead you in that direction by saying, what can you say about the relationship between AC and BD? But this is not true, because, for example, what if A is -1, B is 1, C is -5, D is 1. If that's the case, then A is less than B, C is less than D, but AC is 5 is greater than BD, which is 1. So you can't say anything is the answer to this. That's an unusual answer. This would not be a MAT question, but the idea here is that there's a bit of a trap that I just want. Maybe I caught someone out. Maybe it was you. I'm a bit sorry if I caught you out with this trap, but hey, no stakes. We learned the thing. Negative numbers are tricky. And I tried to help by putting this second part of the question that says, what if the numbers are positive? What if A and C are positive? And if A and C are positive, then B and D must be positive as well. And if you're playing with positive numbers, then this is okay. AC really is less than BD. And you should think about that. Okay. There's a clue in the question that positive numbers are relevant. So I'm really sorry if I caught you out by surprise negative numbers. But hey, now you've seen that negative numbers can trick you with inequalities. Good, yes, okay. One request in chat for question 6. The sum of the coefficients. Sum of the coefficients is not too bad because the sum of the coefficients is the same thing as plugging in x equals 1. So the idea for that question is that you do it for x plus 2 to the power of 3, and then you get the answer 27, and you think, wait a minute, that's a cube number, that's 3 cubed. And then the expression is a cube when x is 1, and then you look back at your polynomial, because this is actually a fact for all polynomials, right? If you want the sum of the coefficients of this polynomial, the sum of the coefficients, 2 plus 5 plus 4 plus 9, is, so if I give it a name, is just the same thing as P of 1. So you can always do this for polynomials. If you need the sum of the coefficients, plug in x equals 1. Right, good, okay. What a silly question, right? What a silly question. Because of course, plugging in 1, like, what does that actually mean? I've presented that like it's a quick way to work out the sum of the coefficients, but here we are. I suppose it is for that second one with the power of 300. I was hoping that you would write 3 to the power of 300, by the way. I was not hoping that you would work out 3 to the power of 300. Really sorry if anybody, I realise now you might have worked out 3 to the power of 300. If you did that, then yeah, really sorry about that. Right, okay. It's 6 o'clock, so quick reminder to look away from the screen and blink. Remember that you are human. I'm going to drink some water. You're welcome to take a break to drink some water. After the break, we're going to do some math questions. I've got some. Let's put one on screen. Let's go for 2014 1G. 2014 1G. Oh, that fits nicely on screen, doesn't it? Okay. Let's just have that. What does chat say? I know you said math is more important, but are maths challenges Olympiads still considered? And should we put it in our personal statement or reference? You're allowed to put anything in your personal statement or reference. I mean, your referee is welcome to put anything in your reference. And some people really find these useful. So some people really find doing maths competitions a way that, you know, competitive people that wants to do a competition for maths. And some people really don't enjoy them at all. So we're not going to compare scores against people. The point of putting things in your personal statement is to make it personal. So I always like it when people tell me what they got out of doing something. So if you list some scores in some competitions, then not very much is going to be done with those numbers. But if you explain what you got out of doing them and why you want to do maths at university, then maybe you can get some sort of valuable experience there. On the other hand, if you do all of this and you write a beautiful narrative in your personal statement, it's all very nice, and then you don't do very well on maths test questions, then it's unlikely you'd be shortlisted for more maths test questions at interview, but I'm getting ahead of myself. Most important thing is actually doing maths, right? So I'd encourage people not to worry about personal statements too much, because writing a personal statement is about writing about maths, whereas for Oxford at least, you get to actually do some maths as well. Okay, and there's another question that's come in which just says, if you use further maths or things not in the maths syllabus to answer a question, can you still get the marks? And the answer is yes. For multiple choice questions, of course you can. You get marks on multiple choice questions for correct answers. For the questions where you type your answers, anything goes. You have to follow the instructions in the question. But if you know more maths, that's not a disadvantage. The questions are written so that you shouldn't be able to say, oh yes, I've seen this in further maths, now the question's easy. So I'd encourage you not to write that because you're probably not correct. But if you engage with the question and you follow the instructions, including things like using the previous result and hence deduce that, or hence use this, or use the previous part, then you can use anything that's logically valid. Good. When do people usually start preparing for this? I mean, you're already preparing for this. So this is a chat question. When do people start preparing? If you've been learning maths, you've already been preparing for this, because there isn't any weird maths on the mat. You don't need to learn any special maths, I hope. It's based on AS level maths. So if you're doing school in England, you've been preparing for this since the start of year 12, maybe before start of year 12, because of the simultaneous equations, right? Quadratic equation, when did you learn that? So you've been preparing for ages. If you mean when do people start doing past papers, my recommendation is have a look over the summer. I'm getting ahead of myself, we will get there. Right, okay. Time to look at this question. I picked this one because it's really hard. I'm interested in how people in chat got started with this. If you've already had a go at this question, because maybe you're working ahead and you've looked at the MAT Livestream page and you've got the worksheet. I put this question on the sheet of past question because it's hard. I've shown it to lots of people, and universally people find this really hard because, well, look, we want a coefficient, but, oh no, the expression has got three things inside the bracket, and we know the binomial theorem, which works whenever you've got two things inside the bracket. So what on earth are we going to do? Aha! Suggestion is to take out the 1. Yeah, there's a 1 plus, right? So if the 1 plus wasn't there, we'd be good. That's a nice idea, I like this. So if 1 wasn't there, that actually says if I wasn't there, hang on, if 1 wasn't there, we'd have x, y plus y squared to the power of n, and then we'd be okay because we'd have two things. Okay, they're not called x and y, but you know the binomial theorem doesn't need literally x and y inside the bracket, it needs anything, a and b. So then we'd be good, because then we would look at this and we would think, aha, that could give me x cubed y to the 5, couldn't it? Depends on the value of n, I suppose. But if, well, could this? Let's just write that it could give x cubed y to the 5 term. Maybe you've got an observation about that, about whether it could or not. Could this give us something that looks like x cubed y to the 5? Let me know in chat. Sadly, though, we will have to deal with at some point the fact that this question has a 1 plus in it inside that bracket. I think we're going to get quite happy about multiplying out this. Yeah, so the suggestion in chat is to take 1 plus and then all of this. I could give it a new name, but I think I'm actually just going to write it inside unnecessary brackets. I see your username. These brackets I accept are unnecessary, but I'm making a point. Look, because now maybe pattern recognition, you can see two things inside the bracket. So this is 1 to the n plus n choose 1, 1 to the n minus 1 xy plus y squared plus n choose 2. 1 to the power. I'm writing out all the 1s, which again I know is unnecessary, but look, it helps make my point, right? There will be a last term. They don't go on forever. There is a last term of something like xy plus y squared to the power of n. As the powers on the 1s go down, I'll write it in 1 to the 0. There we go. As the powers on the 1s go down and the powers on the bracket go up. But this is quite nice because the things that we've got in here are things like this for different values of n. So suggestion in chat, n must be 3. Aha. So if n is 3, suggestion in chat, then you get things, well, do you get things like x cubed? I think maybe you do. Oh, well, so you get x cubed as one of the things you get if n is 3. But it will be matched up with a y cubed. So I see where n equals 3 has come from, but I need you to interact with this 5 as well. Because if I set n to be 3 in this expression, I'll get x cubed, y cubed, which is not quite what I want. Oh, and x to the 4, y to the 4 wouldn't be what I want either, so maybe it never happens, right? The first term there. N is so a different person in chat says n is not necessarily 3, which is we're back to we don't know. Okay, and then there's some more suggestions. I'll let chat carry on thinking about that, because this is a two-part question really. There's one part to, I would say, do an expansion like this, to split it into two terms. Doesn't actually have to be these terms. I quite like the one where you pull out the x separately. And yeah, I quite like that one. And then a separate part of the question to work out how to deal with this xy to the y plus y squared to the power of n. When does that give you x cubed y to the 5? There's something stupid n there. Yes, we could try small values, couldn't we? We could try 1 plus xy. I like that as well. So there are kind of three ways to split up this bracket in this kind of slightly silly way that I have over here. But there are three ways you could do that, because 3 choose 2 is 3. Welcome to the algebra session. Yeah, Mr. Anon says they want 1 to the power of n minus 4. So I think chat is approaching. The third one has appeared in chat, which is y squared plus 1 grouped together. Let's get quickly, if I take the chat on screen, yes, I can get Joe and Anonymous, who are suggesting the other ways between them, the other ways to pair up terms. They work as well. This one's quite nice. I think in this way around of thinking about things, the power has to be 4, which we're applying this, aren't we? This was our hypothetical up here to say, what if the 1 wasn't there? Whereas in here, I think the term I want out of here, the term I want in here, the one that's interesting to me, is not xy. I want x cubed y to the 5. It's not xy all squared. The term that's interesting to me is actually the one with a 4 on it. Now I accept that the one with the 4 on it will start by giving me x to the 4, y to the 4, which I don't want. But then the next term down is the one that I do want. The thing about doing this power is the kind of total exponent. If you add together the exponents on the x and the exponents on the y that you get, over here it's 1 plus 1 and over here it's 2, but 1 plus 1 is equal to 2. So inside you have these things where the total power is 2 on both terms, which means that all the stuff you get from squaring, including the cross term, the total exponent is 4. That's not really what I want. I've just made up this phrase total exponent, by the way. It's not a real phrase. I want the total exponent, if you like, to be 8. 3 plus 5 is 8. So I want to go all the way to get to n choose 4, 1 to the n minus 4, xy plus y squared to the 4, because I want one of those terms. And this comes from the realization that way up here could give this if n is 4. But then this is being applied. It's not literally telling me that n has to be the number 4 in the real question that's printed with the 1 plus in. It's telling me that I should look over here. I should try and find that in the crowd. I should try and find the one with a power of 4 on it. Good, right, okay. Yeah, so I want that one. But then I want, out of that, I want the actual coefficient. So I want the one where I get 3 x's. Which is the second one down, so it's 4 choose 3. So my final answer is n choose 4, 1 to the power of n minus 4, 4 choose 3, which is a bit of a silly answer. Maybe I should recognise that this 4 choose 3 is the number 4, and that 1 to the n minus 4, oh, wait a minute, that doesn't matter at all. So I get 4 times n choose 4. Oh, that's option D on the screen. Yes, Anonymous says a worse way of doing this is to just check the options. They've called that cheating. That's a bit strong. You are hoping that you're combining together here your knowledge that it should start existing when n equals 4, which is not obvious. You're combining that knowledge with looking at all of the options, including this last one, to look at when they exist. I don't think that's cheating. I think that's being clever and then eliminating options. Yes, and Nathaniel at the top of the screen there has a write-up of they've called it an internal coefficient, which I quite like. Out of the crowd, which one do you want? You want that one. Okay, and it ends up being a kind of product of these coefficients because two things have happened. Binomial expansion inside your binomial expansion, because I heard you like them so much. Oh, and I missed a few things. I missed loads of things in chat. Let me reread chat a little bit. Yes, choices. Always choices. Does this scroll live? If I put this back on the screen, does it scroll with me? It does scroll with me. Amazing. Right, I missed some chat stuff. N could be anything. It's not relevant to the question. Yes, but thinking about this other question, where what if the 1 plus wasn't there? Then actually n would be 4, and that gives you an interesting insight. And I missed some chat about this is very nice. X to the a, y to the a, y to the 2b. How big do you want a to be? How big do you want b to be? This one over here. Oh, that's highlighted quite dark, hasn't it? 3 xy's, 1 y squared, and the rest 1's. And they've spotted that, yeah. This thing I've got over here, if I write in the x's and y's at the end, then what I've got is x, y cubed, y squared to the 4 minus 3. So 3 of these, 1 of those, loads of 1's. They're thinking about choices from the brackets, perhaps. Lovely. I like it when chat has other ways of thinking about this. Are there any quick tricks of binomial combination questions we can apply to multiple choice questions? I think what I'm currently at the point of telling people just how to do the questions. Quick tricks come later, right? Once you've got maybe faster at recognizing the sort of things that you get out of these expansions. So I think that the thing here that you need to recognize in the question is it's not really a quick trick about doing anything with binomial coefficients. The trick is to realize you can use binomial coefficients at all. I mean, they're printed in the options, but where do they come up? We should do some sort of binomial expansion, but how? And that's the idea. So no kind of quick tricks for that, but deciding that you're going to do something like this. Do I have pointers on? I do have pointers on. Something like this over here. Deciding you want to try something like that is, I think, the way to make progress with this question. Which is not really like a trick that you probably haven't used before. Okay, and I can do math says you can do n choose 1 for the y squared term, and then separately now you've got to choose from the other stuff n minus 1 choose 3, and they've got to factorize that. Oh, have they got to work with this? So they've ended up with, hello, I can do maths, n choose 1, and then from the remaining terms they've got to choose this, and then you get it stuck. Well, not stuck maybe, but then you've got a slightly different form of the answer, haven't you? So you need to deal with the fact that this is n multiplied by, so that's n choose 1 is n, and then n minus 1 choose 3 is this. Which is the same thing as n times n minus 1, n minus 2, n minus 3 over 4 times 3 times 2 times 1. Except, wait, no, I just made up that 4. I should multiply by 4 upstairs as well. So you get the same answer as 4 times n choose 4, but you've got to, if you've got this product, you've got one last step. I like your argument, but you've got one last step where you need to break these things open so that you can compare them to the things printed in the options. That's a bit tough. We can't have 2 of the options be correct, so we can't give you 2 different equivalent expressions that are both correct. So sometimes you'll find that you get an answer that doesn't quite match one of the things literally printed in the answers, but which is equivalent. So final step there. Sorry about the extra step. This is nice. They're choosing one place to be one of the brackets to be the one that gives us y squared, and then they're choosing 3 for the others. If you think of that as a big bracket multiplying exercise, because you did my exercise from an hour ago, big bracket multiplying exercise where mostly you want to pick 1s if n is large. Okay, what next? You tell me. I think part of the idea of this live session is, well, that I show people tricky maths questions and we talk about them, but partly, if you're here live, you get some say about what we do. There is another multiple choice question up here. Looks like this. It's an inequality with a power of 4 on x. Or we can swap. There's a couple of long math questions. There's something about multiplying out lots of brackets, and there's something about a cubic. So if you want to look down here, past all the hints, there's this 2015 question 2, which has got something about doing lots of multiplying out and thinking about prime numbers. Page of hints for this. If you want this worksheet, it's on the MAT Live page. You can get it at maths.org.uk/r/MATLIVE. There's this question with a cubic in. What should we do next? Up to you. Oh, right, okay, it's a bit bright now. Just letting chat decide what's going on. I'm going to leave this one on screen for a second. Chat says the inequality question is trivial given the options. I think something that maths has got better at over time, if we're talking about this, both of those short questions are from 2014. All of the questions I've picked for the worksheets are from about 2014, plus or minus. Something we've got better at in the last 10 years is writing questions where the options are plausible. More plausible? What's the right word there? More plausible. Some of the old questions have gone. One of the options there was 2 to the n for the coefficient, which just doesn't feel right. Why would you pick 2 to the n for that? 2 to the n is like the sum of the question. It's a different thing. Believable is a good word. Thank you, Liz. Right. Okay. Where can you find the worksheet? Right. Okay. Let me do the thing. Well done for finding the live stream. Nice to have you with us. Let me show you. This will blow your mind. It's going to be amazing. Okay. There is a whole website for this with. Oh, I've not cut. Blam. There's a whole website for this. www.maths.org.uk/r/MATLIVE. You know you're in the right place because it's got the same colour scheme as this, if you can call this a colour scheme. And this has got a link to the live stream where you currently are, a link to chat where you currently are, and it's got this table of web versions. So you can have a look at questions if you want to see them in advance, or if you want to print them, there are PDFs here if you want to print the version, and it's the PDF that I've got literally on screen. For the proceedings, a few votes for this one, and a few votes for 2015 question 2. So I think we'll forget about the inequality, and I'll try and do this for 20 minutes, and then maybe the other one for 20 minutes. Let's see how that goes. This one's tricky for my setup because the question is very tall, and I'm doing something funny where I've got a landscape video and I'm trying to split it in 2, which means a little bit like trying to watch maths through a letterbox. Had some feedback that I got once. Why is this guy doing maths through a letterbox? But here we are, doing maths through a letterbox on YouTube. Let's look at the setup together first. So it's the graph of x cubed minus x and some straight line with gradient m for mystery. But we're told that's a positive number, and a is less than, oh my goodness, okay. The intercept is less than or equal to -1. So quick thoughts. They've given me a sketch, which is nice, and I suppose the relevance, what happens when a is equal to -1? And they give me an inequality. I sometimes want to think, what's going on there? And I suppose there is a root of that cubic when x is -1. Yeah, so going on the left. Yeah, so Anonymous has come up with the correct solution in chat, which is that I should have gone left-right for the split rather than my actually excellent, I think, up-down split. But here we are. Maybe I'll develop that. The questions are very wide, by the way. So the reason for doing that is that if I zoom this question out until if I fit it on half the screen, the text gets really small. So there's method to my madness as always. Right. The line meets the x-axis at A0, yes it does, touches the cubic at B, interesting, and intersects again with the cubic at C. Oh, right, and now we're told that A is less than -1, so I need to fix that. Okay. This question's modified, and I realise I've introduced something a bit silly when I modified it. I added a fact about A, which I now see is already in the question. Good, okay. So here's what we're asked to do. We're asked to do several things. So I need you to remember that we have the cubic x cubed minus x, a straight line, and those things touch when x equals b. Let's go. So let's put the question there and put my postbox down here. I shouldn't have said that because now everyone's going to make fun of it. Like that. Yes, so we should think about the gradients, I think. M on the left of this expression, we're told to prove that m is equal to 3b squared minus 1. M is the gradient of that line. And if a straight line just touches a cubic, then that means that at that point of x where it just touches, they've got the same gradient. I suppose I'm thinking about a kind of differentiation from first principles kind of thing, where you imagine that if it just crossed, that would be like having a little bit of if this line just crossed the curve, there would be 2 points, and then if you correct that, you bring it up a little bit so that it just touches. If you correct that, then you're bringing the points closer together, so you're doing the differentiation from first principles thing. All I'm trying to say is that the gradient at this point should match. And on the one hand, the line is this, so it has gradient m, and on the other hand, the curve is this, so it has gradient 3x squared minus 1 in general, and at b in particular, that's 3b squared minus 1. They're supposed to be equal because the line just touches the curve. You can use this fact in general if you like. If a line just touches a polynomial, then they've got the same gradient at that point. Cool, that's the first part. And then we're told to show further that, and I suppose my thought here is that I haven't yet used the fact that they have the same value. So we're told show further. We're asked to show further that A is equal to, and then some stuff. And I haven't yet used the fact that as well as having the same gradient, same value, they have the same y coordinate over here. So m times b minus a is supposed to be equal to b cubed minus b. This is the value of the line, the y coordinate of the line, and this is the y coordinate of the curve at that point. So I need to check, is this going to give me the right thing? Yeah, I reckon this is going to give me the right thing. I'm going to have to do some work, but it's going to give me the right thing, isn't it? So I'm hoping that this just rearranges and does exactly what it's supposed to. Let's find out. So I'm going to divide by m. Oh, I'm going to remember that m is 3b squared minus 1. I'm using the previous part of the question. We know that now, so I'll write that out on the side because m is equal to 3b squared minus 1. And then I want a on the left, so I'm going to try and do b minus, I'm writing down here. I'm going to try and do letterbox. I'm going to try and do flip that around, so a goes on the other side, this comes round. Hopefully this simplifies. So 3b cubed minus b minus b cubed minus b over good. Minus. Hooray. Okay. Yes, so you could differentiate both if you like. I was a bit cheeky, wasn't I, with it instead of differentiating this straight line, I just write down its gradient. Like, that's a formula that I know. The gradient goes here. You could differentiate both, set them equal. The point about just touching means they've got the same value and the same derivative. The y values are equal and the y prime values. Nobody says that. That's not a thing that people say. Okay. See how that built on the previous part, right? That 3b squared minus 1, which looks scary in the second part of this question. There's like 2b cubed over 3b squared minus 1. Ugh, yuck. But if you remember that 3b squared minus 1 is m, then it's not so bad. There's a nice simple expression on the right-hand side. So if you bear in mind that you recognise some of it, you can use the previous part of the question. And in part 3, my preference is to just do something like that again, because now I have a fact that relates together a and b. So I know a equals 2b cubed over 3b squared minus 1. And now I'm told that a is negative 1 million. I'd like to know what to do. The equation of the line is... Where's the equation of the line? Good chat comment, I like it. The equation of the line is... I think the equation of the line is y equals 3b squared minus 1, that's the gradient that we found on the previous parts, times x minus a, which I think is all this. Which does simplify down. It gives, if you like, gosh, sorry. I think the equation, this is the gradient, 3b squared minus 1, minus, and then the value of a is 2b cubed over 3b squared minus 1, which simplifies a little bit and gives me this. But I have this on the end, which is not a. A was, yes. Point A was a comma 0. Okay. Not a bad idea. Let's multiply it out. Let's work out what's going on. Let's get this mystery solved. We know everything about the line now in terms of b. I don't think we know what b is, but we're about to get there because we're told a is minus 1 million. What's the approximate value of b? So, question. When is this expression on the right equal to negative 1 million? I mean, when's it negative? We're told in the question that b was negative, so that's a good start. But wait a moment, if b on the top is negative, this thing is negative upstairs, so I want this thing downstairs to be positive. I know b cubed is negative. I hope that 3b squared minus 1 is positive, which, if I think about a little quadratic, that tells me that I hope that b is on the left of, I suppose those are the turning points of the cubic. Picture time. Having a quick look at the picture, I guess I'm hoping that b is on the left. I mean, geometrically it has to be, doesn't it? There has to be some point over there where you have a line going through capital A on the x-axis, and you just choose the line to just rest on the cubic, and that point will be on the left of the turning points. Okay, so it seems plausible that such a point exists. I'm being asked what happens if a is negative 1 million. So when is this large? When is 2b cubed over 3b squared very negative? These are the sort of questions that go through my head, right? When is this very negative? How can I make this large in magnitude? I guess my thought for that is, well, I could make the number b very large as well, but I'm told that b is greater than a, and a is, I'm told that b is greater than a. I don't really want to be miles to the left. Is that right? Maybe that's right. Yeah, I don't really want a to be 2/3 of b. My next thought is that I should make 3b squared minus 1 small. Yeah, geometrically, here we are on the algebra geometry divide again. I tend to do things algebraically when I can. So I'm looking at this expression thinking, ooh, can I make this a very negative number? And for me, it's like a numbers question. I have a fraction to play with. I could make the top a very large number. That works out because I can make the top much larger than the bottom if I make b an enormous number. But I've thought about it. I don't think that's what I want. Because in the picture I can see roughly where b is. B is supposed to be larger than a. So I mumbled to myself about making b very negative, which would make this approximately 2b over 3. 2b over 3, which is 2/3 b. But a is supposed to be even more negative than a. A is supposed to be even more negative than b. So new idea. Instead of making b a very negative number, I should make 3b squared minus 1 very small. So this is me being very algebra minded, but of course you could be geometry minded about this. You could imagine in that picture up there what happens when a goes to the left. Minus a million is very far away. And if you go very far away, then this line is coming in very at a very shallow angle, if you like, which means that when it meets the curve, it's got a very shallow angle to it. It's very flat, which happens very near the turning point. If you rest this line, if you rest a line on the cubic with the point of intersection with the x-axis miles off to the left, then you could achieve that if you set the line near the turning point. Yeah, right. Point a0 must now be a positive axis when a is negative. I hope not, because a is supposed to be a negative number. Okay. So there are two cases. One I mumbled about to do with 2/3 b, and the other one when 3b squared minus 1 is small. I suppose the other case comes from if you take a quite a steep line through a, it could be tangent to the cubic again, not like in the picture, but with the line tangent to the curve somewhere on the left. If you can imagine that. So I'm imagining taking that line. Let's try and draw it your way around. Taking that line and tilting it the other way until it's tangent with it around a, moving it around a until it's tangent with the cubic at a different point. I think that one would be at 2b over 3. Not really in the question. Right. Okay. Good. Final answer then. When b is about, it's supposed to be negative, so negative 1 over root 3. Turning point. Which I think probably people were more likely to get to with geometry than with algebra, thinking about numbers. Okay. Yeah, so I want b to be just I want this to be positive, but only just. Only a little bit positive, so that I get an enormous number like negative 1 million. Good, okay. Using the fact that, which you need not to prove, oh, my heart. I read the statement, I think, I'm going to have to prove that, and it says you need not to prove. Show that c is equal to minus 2b. So I've got an expression there for the polynomial. On the left I can see some sort of expression. I don't get it yet. And on the right I can see some sort of polynomial. I can see some factors, so I'm slightly thinking factor theorem. And it says show that c is equal to minus 2b. So I think I'm imagining what I could plug in to get the value of c. I mean, I could multiply it out. I could multiply it out on both sides. This expression at the top, this thing they've given me. I could multiply it out. That feels like work. So I think I might just try. This is cheeky, but can I just like try x equals 1? Trying x equals 1 will give me some fact. If this is true, they give me this fact, which I need not prove. 1 minus 1 minus m 1 minus a is equal to 1 minus b squared 1 minus c. And then the question is, I know m in terms of b. I know m in terms of b. I know a in terms of b. So I could rearrange that to get an expression for c. But I've realised while I'm writing that out, I've realised a better idea. So I'm going to keep doing this unless someone in chat tells me a better thing to do. There's the deal. I'm going to do this. I'm trying x equals 1. They've given me this big fact. I've decided not to multiply it all out because that feels like work. Too much work. I've tried plugging in x equals 1 because I've realised that these things would cancel, and it will give me a fact with no x's in that says something like minus 3b squared minus 1, 1 minus, and then this a is 2b cubed over 3b squared minus 1 equals 1 minus b squared, 1 minus c. So I was going to then multiply it out, divide by this, do 1 minus, but we've been saved in chat by Bliss, thank you Bliss, who says, that sounds like too much work, let's try x equals 0 instead. And if you plug in x equals 0, thank you, then you get, I don't know why I've written that one out, I think I'm making a point, there we go, you get something much nicer, which is same sort of idea I suppose. I still need to multiply m and a together, but now that's a little bit easier, and on the right hand side things are much easier. So this looks quite a bit nicer as a way to work out what m and c are. I'm missing a minus sign, I'm missing this minus sign here, I've decided. So that simplifies down quite nicely to c is minus 2b. Yes, thank you Figroll as well, good. So maybe this is easier as a spectator to spot this thing that James is doing is stupid. You should do something different. I would encourage you to try and be a spectator for your own maths as well. That while you're doing something, a small part of you, not a big critic, not so much that you never get anything done, but a small part of you should be thinking, is this all, could this be slightly different, right? So you shouldn't write this out and think, oh, maybe if I plug in minus 3, then actually it will just give it to me straight away and I won't have to rearrange. You know, you've got to be willing to do some rearranging. So not too loud a critic, but possibly, ooh, I'm close, but if I'd done something slightly different, it might be slightly easier. Good, okay. It's quite hard to have that bit of your brain going at the same time as the bit that's actually doing the algebra. That is part of fluency, I think. Fluency is this skill about being able to do these calculations without thinking about literally what you're doing too much and still getting the right answers. So that you can free up parts of your brain to think about more interesting things, like what am I going to do next? What can I see? What does that make me think? Ruben has got a great question in chat, which is, why is it not that? And I think that's an acceptable answer. Minus 1.5 million is an acceptable answer, except in the question, so if A is 1 million, B being minus 1.5 million is pretty much fine, except there's this fact just before the picture, A is less than B is less than 0. So that rules out that case. And story time, in 2011, I think the question didn't have that. It's why it says modified at the top. I've modified this by putting in some extra terms and conditions to try and say, not that other solution. And I think the version that was used in 2011 had 2 solutions. So for the question in 2011, if you did this test 14 years ago, then I think you would have got credit for either of them because there were 2 solutions. I thought that was inelegant for the MAT Livestream, so I've tried to edit the question to ban one of them. Maybe that's inelegant. Elegance is hard, isn't it? Right. Split view again. We've got a last part of this question, which tells us to do some integration. And to be honest, I might leave this. There are now no mysteries to us. We've got so much that we know. We know A and M and C all in terms of B. So everything's good. We would like the region R, so I need to draw this and this, and mark the region R. For the region R, I think I would do, so to be honest, I would subtract these and I would integrate. An option available to you if you don't like to do that is to draw in these vertical lines. Where's the x-axis? The x-axis is in here somewhere. An option available to you is to draw in these vertical lines maybe this horizontal line, so there's a kind of trapezium in there. If you don't like trapeziums either, you could draw in this horizontal line, and then what have you got? You've got something to do with integrating the curve, something to do with a triangle, something to do with a rectangle, and you're all good. R is made of rectangle plus triangle minus the integral of the curve, which gives you the same answer. But to be honest, I would do the integral of mx minus a for the line minus x cubed minus x for the curve. Unnecessary brackets around the outside. Maybe you've seen a thing like that, or maybe you know that this gives the same thing as drawing trapeziums and squares and rectangles. I don't think I'm going to encourage anybody to do this question twice, but maybe something to think about is the difference. We've got an integration live stream coming up in about a month's time, where we'll talk about this as one of the things that we talk about. B is 10 times the cube root of 500. That sounds quite large. Wait. Oh, that's a number. And then it says value of A is the area of R, the largest. So I suppose I'm doing this. Am I doing this by factorizing, or am I doing this? No, I don't want to factorize this. I just want to go for it. I just want to integrate it, right? This is B up to minus 2B for the integration. Okay. Those brackets are not unnecessary, someone says in chat. They wanted those brackets. Good. I wanted those brackets too. Yeah, so I regret drawing on this x-axis because actually nothing changes if the x-axis is lower down. It's something we'll talk about in the integration live stream that you might like to think about. But if you take those two functions and you add some value to both the line and the curve. So I'm suggesting that let's group all of that together. I'm suggesting that you imagine taking the curve and the line and adding some value. Well, if you do that, then what happens is the x-axis, group it. Here. The x-axis shoots off down here. The values are now really large. They're way above the x-axis. But the area of the region R is still the same. So this suggests a sort of property that if you're finding a region between two curves, then you could add a constant to both of the curves, or lines, or whatever they are, add a constant to both of them, and that's a translation up and down, so it won't change the size of the region. We've got a live stream about translations and graphs coming up as well, so this is all connected. There's something going on where you can translate this thing up and down, it doesn't change the area, and that means it doesn't matter where the x-axis is. Move it up high enough that it's above the x-axis, and then you don't have to worry about the x-axis. So it's kind of weird, right? Just to highlight that thing in chat is the thing. Part of the reason I talked about that is partly because it was a good question and it was an interesting topic, but also partly because it's got a couple of thumbs ups, and you can thumbs up things in Slido, which helps me notice them. It's just like social media. No, it's nothing like social media. Right, I'm not going to do that integral. If I did, I would get some sort of expression, and then I would maximize it by using differentiation. And spoilers, if you look on the website, you can get the worksheets. You can also get solutions, where I am not lazy in the solutions. I've gone through all the steps, and the answer turns out to be 27 over 4 times b to the power of 4. So it's not even differentiation at the end. It's just saying you can make that large by making b as large as you'll let me, or as negative as you'll make me, I suppose. As negative as you'll let me. Good. And you get a polynomial in b, which you would differentiate. And the polynomial turns out to be actually so nice that, remembering in the context of the question, I've got some bounds on b. B can't be anything. There's a diagram in here somewhere. B is, and some inequalities if you prefer that. B is greater than a. Why do I think b is greater than minus 1? Why do I think b is greater than minus 1? It's weird, I really think that b is greater than -1. Well, in the picture, it's drawn so that b is up above the x-axis. Why do I think that's happened? Because we've chosen that branch. It's the same thing as the 2011 issue. Okay. Can the expression be maximized intuitively? Here's a geometry person in chat. I've been mentioning this, that geometry algebra people. The algebra approach is very much, I would integrate that and find the area, and the geometry approach is, think about the picture, right? Think about what's actually going on. You want to make that area big, you should move b left. If b is left, for whatever reason, I guess actually we're moving a, so if b was left a lot, then you get a lot of area. In fact, that's true. You move b left as far as you can by bringing a closer in, so that it's tangent closer to the root, and then you get loads of area. I would do that. Yeah, when a equals b equals -1 gives you a big area, and that does give you 27/4. So there you go. Good. Okay, let's have a quick look at the ideas in the other question. So I'm going to scroll up and look at the ideas in this question. That is hints. So if you want hints, we can go there. I'm going to go full screen. Okay. So here's the question. It starts by asking you to expand and simplify, and this is a good point for me to remind people that in 2025, the long questions on the MAT will be answered by people typing using a normal keyboard, and you would not be expected to type out all of that, expand and simplify. Oh my goodness, there's loads of terms. But in 2015, people did expand and simplify that. You should try this on a bit of paper or whatever you've got at home. If you do, I hope that you multiply out some terms, so multiply out that bracket by, I guess, multiplying the big bracket by a and multiplying the big bracket by b, and then getting quite a lot of cancellation, which is exciting because it gives you a simple answer. The simple answer is a to the n+1 minus b to the n+1. This question has got connected parts, but I want you to notice that it doesn't tell you that the parts are connected. The first 4 parts of this question all go together. The 5th part is a little bit separate. It's thematically linked but different. But the first 4 parts definitely all go together. You know, maybe you could make an argument the 5th part belongs with them as well in the same sort of logic. But here's exactly the sort of question. Right. So I think this question comes from an earnest place. I'm just going to put it on screen so you can see it. Could it be worth learning the Unicode code point for sigma so that we can type it in the MAT? And bless them, they've also learned the Unicode code point for sigma so that they can type it in chat. So obviously we're not expecting people to do that, which means that the questions are written so that you don't need to do that. So I'm sorry that you've learned the Unicode code point for big sigma. I hope you get to use that somewhere else as well. But it's not a test of whether you can Unicode math symbols. That is not what's going on. Trying to think of a good analogy. Yeah, no, okay. Right. Would this thing not also be a valid simplification? Correct, I'm afraid that would not be a valid simplification because it's missing all of the binomial coefficients. Where before, the thing on the screen there is not the binomial expansion of a plus b to the power of n, because where are the n choose r's? They're not there. Okay. So there's connections between the parts. Let's talk about those, because those are more interesting to me than actually doing all of the bits of the question. Part 2 talks about primes that are 1 less than a square number. Are there any other prime numbers with this property? Justify your answer. Possibly you write down something to think about. 1 less than a square number, to turn that into algebra. 1 less than a square number means that it'd be something like a squared minus 1 for some whole number a. That's exactly what it means to be 1 less than a square number. And if it's a squared minus 1, then it fits the pattern of the thing you were talking about in the first part. A squared minus 1 is the thing that you had in the first part, but with n equals 1 and with b equals 1, which means it's a minus b times a plus b. But maybe you already know that as the difference of two squares, right? That a squared minus 1 is just a minus 1 times a plus 1. I mean, it's a polynomial, you can factorize the polynomial. A squared minus 1 is a plus 1 because it's got a root at minus 1, and it's a times a minus 1 because it's got a root at plus 1. It's all connected. Roots, polynomials, prime numbers, squares, whatever. So that's factorized. You need to know what a prime number is, but you've made great progress by factorizing this expression. I think that's all we need to say about that one, isn't it? The third part, which says one more than a cube number, the skill here is going to be to work out how the thing that you did in part 1, this way of factorizing an expression, to work out what that's got to do with one more than a cube. Let's write out the thing that we've got, because I've said it out loud, but I haven't written it down for you. Probably you found in part 1 that this thing, oh no, now I'm writing out all of it. I don't have to write this well because everybody can see it at the top of the screen, but here we are. B to the n plus b to the n. It's equal to, like this. And part 3 of the question, part 3 is this question is about numbers of the form k cubed plus 1 or something, one more than a cube. I'm writing k because I don't know what it's got to do with the other stuff going on. So is that like this? If these are the same, then we're good because, well, I can factorize an expression like this. Crucially, the thing we did in part 1 is to expand the brackets, but you can go the other way. You can now use this as a way to factorize this expression. Difference of two n plus 1 powers factorizes. The solution bank. Oh, thank you. In the solution bank, there is no answer to part 3 of this question. Ooh, that's an oversight. I've got a solution on my PDF that I've printed. Maybe you mean the MAT website? Maybe you mean the MAT website, or maybe you mean the web version. Solution bank, they say. Interesting, okay. Have I missed a solution off? I'm checking live. I found a hint. Oh, I'm looking at hints. No? Solutions. Okay, keep me posted. Like in chat, this person has. Yeah, that's the squares. And there's something else going on for this next part. We've got about 3 minutes left. Yes, this is me wrapping up, believe it or not. Yeah, no, I've got that on the web as well. Maybe they mean the map page. Okay, see if we can find a place where that's missing. They edited down to 2. Right, okay. The countdown is on. Okay, these things are related. If you set, so n plus 1 powers here, let's put a 1 cubed in here. So if you set n equals 2, these things are related. If you set k equal to a, and if you set b equal to minus 1, so the plus sign here could secretly be 3 minus signs and another minus sign. 4 minus signs. Oh my goodness. So if you like, then what I've noticed is that a to the n plus 1 minus minus 1 to the n plus 1 is just a to the n plus 1 minus, and then a whole bunch of minus 1s. So it's not too bad. Oh, part 4, you meant part 4? Part 5? But yes, okay, so part 4, yeah, no, I agree. I agree. The solutions doc is missing part 4. Yep. It is absolutely missing that, about 3 to the 2015. Yeah, let's talk about it now. I'm going to overrun very slightly, I think. So this thing with the big difference of two prime numbers, again, the question is, how is that related? And you might try and just plug in a equals 3, b equals 2, but then you get this factorization. So we've been trying to avoid these factorizations where you get 1 times something, because even primes have a factorization that's 1 times something. So we could write this out as 3 minus 2 times, oh my goodness, all the other stuff. But actually that's not very interesting, because that tells me it's 1 times some big sum. The question is whether it's a prime number, and that's not helpful, because even primes can be written as 1 times something. When I say even prime, I don't mean 2. So maybe the idea is to use something else. So IV, I agree, IV is not there, and then part V is labelled part IV, which is confusing and weird. Good. The trick then is to find a different way to write this as the difference of some powers. In words, that's what we've got up here, the difference of some powers. And there's lots of ways to do that, actually. If you spot that by power rules, this is something like this, and then you can use the fact that this factorizes like this, with A is 3 to the 5 and B is 2 to the 5 times, oh, I don't want to write it all out again, but all of that stuff in there. And that's a non-trivial factor. So if you find a different way to write this expression as the difference of some powers, then you can pull out a non-trivial factor of A minus B from, there's the expression up there, A minus B. But you need A minus B not to just be 1, because that doesn't tell you anything. You want a non-trivial factor. Okay. Yeah. 3 is 4 minus 1. What's this chat message? 3 is 4 minus 1 is 2 times 2 minus 1. Quick maths. What's going on there? Yeah, I get this question every year I do the MAT Livestream. I was just waiting for it. Should we learn the prime factorization? Because what I did there was I found a factor. I didn't need the prime factorization. I needed a factor of 2015. And I've been waiting, like, I guess 10 years for this, because the year is 2025. That's a multiple of 5 as well. So this maths on screen, very similar for 2025, would work, wouldn't it? You don't need to be able to factorize 2025. I reckon you probably can, though. You know, if you needed to, or if you wanted to, I reckon you probably could factorize 2025. It's got some pretty good factors. You should look into that. It's got great factors. Right, okay. I'm going to wrap up there, I think. There's this last part, which is a bit unrelated, to say, could that number be a cube number? The method for that, I think, or the hint, is to think about how large that number would be in comparison to things that you recognize. I mean, that is not k plus 1 cubed. It's close to k plus 1 cubed, isn't it, in pattern, but it's not k plus 1 cubed in value, because you know what you'd get if you did k plus 1 cubed. That's my way in, I think. I look at it and I think, has somebody done typo for k plus 1 cubed, right? Like, because if it said 3, 3 in the middle, that would be k plus 1 cubed, and the answer would be yes. You know, is that a cube number? Yeah, it's k plus 1 cubed. But they've done 2, 2 in the middle instead of 3, 3 in the middle. So the difference there is the key to understanding the question. Yeah, people in the chat have got all of their favourite 2025 facts. Oh, Anonymous has learned how to do the little 2 upstairs. You don't need to learn this if you're watching and worried that you need to learn how to type small upstairs numbers. Oh, my goodness. 3 to the 4 times 5 squared. Yes. That is the prime factorization of 2025. Right, okay, everybody knows it now because Rosie's told us, right? 3 to the 4 times 5 squared. Join me next year when I'm asked. I'm aware that other tests do this. UKMT does this quite a bit. Presumably they're doing it quite a lot now that it's got such a nice factorization. Matt's a bit less keen. We used 2015 and 2015. Not sure we've got other ones. No, Joe, I think 2 factorial is 2, so then 45 to the power of 2 factorial would just be 2025. I think it checks out. I think it's all right. think it's an expected factorial. We're all okay. Provided you do the factorial first and then the exponentiation. I think that's all. I like it when it works out, even with the factorial. See also 1 factorial. Right. Okay, good. I think I'm going to wrap up here. It's 7:05. Am I going to wrap up? I'm going to do the cube calculation. Do some other ones. There's other possibilities. So when I write in the solution, which I'm going to have to go and do, we're going to get a... I've been using that worksheet for years. Maybe people tell me this every year. I'll watch the replays, see if people tell me this every year and I keep forgetting to do it. 2015 has got other factors, right? So we can pull out other factors of this number. I mean, in 2015, I don't know if you can see this, but 2015... Wait, does it have other factors? I thought I was going to say it was multiple of 3, but I'm aborting this. I don't know if 403 is prime. Let's Google it. Is 403 prime? AI overview says no, but I'm not happy. Table of prime factors. What a great list. Is this actually, have I actually caught Google being bad? 13 times 31. Wait. No, this is good. I've not called Google. Okay, I thought I discovered AI being really bad, but AI being actually useful. I would not be able to factorize 2015. So maybe this is good evidence then. Maybe this is evidence because... No, this doesn't quite work as a sentence, does it? The point I want to make is that for MAT, we don't expect you to be able to factorize the year, even if the year is in a question. Because look, in 2015, we had this question with 2015 in it, and it would be really unreasonable to expect people to factorize 2015. For example, I can't. Yeah, that doesn't work quite well as a thing, does it? When it says justify your answer, the reason for that, sorry, chat message, justify your answer. Oh, that's the sum of cubes fact. Very good. Your phone keyboard has the cool upstairs symbols. Okay. Yeah, okay. When it says justify your answer, are your workings your justification? Yes, quite often. In a text typey thing, you might be typing some explanation. That often appears on questions which are yes-no questions. And it's an indicator that you don't get very much credit for just saying yes or no. So what have we got? In the question, I can see... in the question I can see explain your reasoning carefully, which is to communicate that you don't get very many marks just for saying, yep, I reckon it is a cube number, or nope, I reckon it's not a cube number. You don't get a lot for that. And in part 3, where you're asked to justify, that's to stop you from correctly listing all of the prime numbers. There's not very many. You might correctly list all of the prime numbers that are one more than a cube number. 2. And then give up, that's the list. But the idea is that you don't get very many marks for just correctly listing them. Even though that's correct, without the phrase justify your answer, just writing 2 would be, I guess, technically correct response to that question. The point is that you're trying to explain this or justify what's going on. So all the stuff you do other than just stating your answer. The point of the long questions is supposed to be that you've got some process or thing that you're thinking, right? You got something to talk about. Yeah, 13 times 31. And Google AI also got it right for me, but I misread it, which tells you a lot about AI and me, doesn't it? Right. Somebody in chat ran a 2-line Haskell program which says 403 is prime, but they missed 13 times 31. Right. On that note, you can use these instead. If we could possibly divide 2015 by 13, then we could work out what was going on. So what does that mean? Oh, split view. What is going on? So 2015. This is, for people watching the recording, in my defense, it's late now. It's like 7 PM. I've been going for 2 hours. I'm now entering the period of the live stream called How do you actually factorise 2015? What is going on? We've got lots of factors there, haven't we? So, 65, that's a weird factor. Do I believe that? This is great. 65, 30, 51, 50. This is what everybody would like, isn't it? I think the show may have finished, but interesting. Interesting. 65 really is a factor. So you can take this and you can say, oh, so it's got factors like this, and it's also got factors like this. But this factor is not prime either, because this one includes a factor of this by using the thing again about differences of powers. So this question is kind of, you get some machinery at the top that you prove yourself, and then you use the machinery 3 times as much as possible. For the short questions are multiple choice. So short questions multiple choice, you click the boxes for selecting your multiple choice answers. For the long questions where you're typing, they've been designed so that you don't need any exciting computer skills. You couldn't hear that, but I said skills with a Z. You don't need any exciting computer skills. Yeah, you'll be fine. Right, good, okay. Chat, we have converged. Both me, chat, Haskell, Google AI have all converged on the idea that 2015 was not a prime number. And neither was 403. Right, good. I think we've reached the point where I should stop. I'll see you next week for another episode of the MAT Livestream. Next week, I believe that we're talking about integration and differentiation. Oh, I think I said that was a month away, and it's turned out to be a week away. Right, okay, next week, integration and differentiation. We can talk about that trick about finding the area between two curves. That's coming up in 166 hours. Until then, have a nice evening, have a nice weekend. I hope that you get all the maths you want in the order you want it, or in a different order, if the order doesn't matter. Right, take care everyone, bye.